In this class, we are going to learn how to find the stationary point of a function. At stationary point, the first derivative of a function is equals to 0. Okay, let's say we have a function f of x equals to 2x squared plus 2. At stationary point, the first derivative of this function f of x will be equals to what? 0. Are you getting it? Now, another important concept that I would like to introduce to you is that stationary point can be maximum. Please pay attention. It can be minimum, and it can be point of inflection. Point of inflection. Stationary point can be maximum, it can be minimum, and it can be point of inflection. Okay, don't forget, at stationary point, the first derivative of the function is equals to 0. Are you getting it? And we can know whether the stationary point is maximum, minimum, or point of inflection. To check whether the stationary point is maximum, minimum, or point of inflection, we use the second derivative test. There are various tests, but in this class, I'm going to be using the second derivative test. Do you understand? Now, anytime you take the second derivative of the function and you obtain a value less than 0, the stationary point is maximum. Okay? Listen to the explanation again. Don't forget, when I start this class, I told you at stationary points, the first derivative of a function is equals to 0. Are you getting it? Now, it is possible for the stationary point to be maximum, to be minimum, or point of inflection. Now, I'm trying to explain. The stationary point is maximum when you take the second derivative test and you have a value that is less than 0. That means that the stationary point is maximum. Okay? So, if you take the second derivative of f of x, if it is less than 0, the stationary point is maximum. If you take the second derivative of f of x, and if it is greater than 0, that means the stationary point is minimum. Now, if you take the second derivative of f of x, and you obtain a value that is equivalent and that is equals to 0, that means that is the point of inflection. Are you getting it? Now, don't forget, at stationary point, the first derivative of a function is equals to 0. Are you getting it? At stationary point, stationary point, the first derivative of a function is equals to 0. Now, stationary point can be maximum, minimum, or point of inflection. At maximum, the second derivative test will be less than 0. For minimum, the second derivative test will be greater than 0. And if the second derivative test is equals to 0, you're going to have point of inflection. Okay? Now, let us look at work example on stationary points. Let's consider this question. Find the stationary point of the curve y equals to x to the power of 3 minus 3x squared plus 3x plus 8. Okay, that's the question. Find the stationary point of the function of the curve. Stationary point of the curve y equals to x raised to the power of 3 minus 3x to the power of 2 plus 3x plus 8. Okay, and also we are asked to distinguish between them. Now, to get the stationary point of this function, don't forget I told you at stationary point, the first derivative of this function will be equals to 0. Are you getting it? Now, we are having a function y equals to x raised to the power of 3 minus 3x squared plus 3x plus 8. The first step is that we have to differentiate this function because at stationary point, the first derivative of the function is equivalent to 0. So I'm going to have derivative of y equals to 3x squared minus 6x plus 3. Okay? To get the value of x, what do? You set this equals to 0. Are you getting it? Because at stationary point, the first derivative of a function is equals to 0. So I'm going to have 3x squared minus 6x plus 3 equals to 0. Do you understand? Okay? How do you get the value of x? To get the value of x, let us factorize. Using factorization method, I'm going to have 3x squared minus 3x minus 3x plus 3 equals to 0. Are you getting it? Now, I'm going to have 3, okay, sorry. Okay, you can put it 3x into bracket x minus 1. Are you getting it? Minus 3 into bracket x minus 1. This will be equals to 0, okay? So I'm going to have 3x minus 3 equals to 0. X minus 1 equals to 0. 3x equals to 3. X equals to 1. To get the value of x here, I'm going to divide both sides by 3. X equals to 1. Are you getting it? So I have x equals to 1 or x equals to 1 or x equals to 1 twice. Now, this is the stationary point. The value of x is 1 and 1. Now, the next question says we should determine whether the stationary point is maximum, minimum, or point of inflection. Okay? Now, don't forget, I told you that to determine the nature of the stationary point or the nature of the curve, you are going to use the second derivative test. Are you getting it? Now, for the second derivative test, you're going to differentiate this function one more time. Are you getting it? This is the first derivative. Now, let us take the second derivative. I'm going to have the second derivative of y is equals to, now, differentiate 3x squared, you're going to have 6x. Differentiate negative 6x, you're going to have negative 6, okay? The second derivative of this function is what? 6x minus 6. Now, having differentiated the function twice, you have to go back to the values that you obtain as your stationary point, which is what? X equals to 1 twice, okay? Then substitute each value. So, when x equals to 1, the second derivative will be equals to 6 multiplied by 1 minus 6. The second derivative of y will be equals to 6 minus 6. The second derivative is what? 0. Now, because you know that for both values of x, what we have is what? 1. So, if you substitute the second value as well, you're going to have what? The second derivative as 0. Now, my precious students, if the second derivative test is equals to 0, is this stationary point maximum? Is it minimum or point of inflection? Yes, it is point of inflection, because at point of inflection, the second derivative test is equals to 0. So therefore, the stationary point that we have here, they are points of inflection. Are you getting it? So we are able to distinguish between them. The stationary point is point of inflection. Point at x equals to 1. Put it like this. At x equals to 1, we have point of inflection. Are you getting it? Point of inflection. Now, listen to me carefully. You can get the corresponding value of y by substituting the value of x as 1 into this equation. So you're going to have, since y equals to x raised to the power of 3 minus 3x raised to the power of 2 plus 3x plus 8. You're going to have y equals to 1 raised to the power 3 minus 3 multiplied by 1 raised to the power 2 plus 3 multiplied by 1 plus 8. Y equals to 1 minus 3 plus 3 plus 8. So y equals to minus 3 plus 3, that is what? 0. 1 plus 8 is what? 9. So x comma y is 1 comma 9. Do you understand? Okay, so the stationary points are 1. The stationary point is 1, and this the nature of the stationary point is point of inflection. Do you understand? Okay, now I have a question for you. Let's assume that when you take the second derivative test, you obtain 2 as your answer. What will be the stationary point? Is it maximum or minimum or point of inflection? It is minimum, because when the second derivative test is greater than 0, it is minimum point. Do you understand? Okay, the stationary point is minimum. Okay, so that is the solution to that question. Don't worry, we are still going to go over more questions as touching this concept. Okay, so follow me carefully and make sure you watch this class till the very end. Okay, let's consider this question on stationary point. We are asked to find the stationary point of the function f of x equals to 2x raised to the power of 3 plus 9x squared, and determine whether the stationary point is maximum, minimum, or point of inflection. Okay, now don't forget that I told you a stationary point, the first derivative of a function is equals to 0, And to know whether the stationary point is maximum, minimum, or point of inflection, we make use of the second derivative test. There are many other tests, but in this class, I'm going to be using second derivative test, okay? Now, let's start. The first step is that I have to take the first derivative of this function. That is, I have to differentiate the function, okay? So, derivative of f of x will be equals to differentiate 2x to the power of 3. You're going to have 6x squared, okay? Differentiate 9x squared, you're going to have plus 18x, okay? Having differentiate the function, you set the function equals to 0. Do you understand? So I'm going to have 6x raised to the power of 2 plus 18x equals to 0. Do you understand? Because at stationary point, I told you, the first derivative is equals to 0. Do you understand? The first derivative of a function is equals to 0 at stationary point. So that is why I set this function equals to 0. Okay? To get the value of x, I'm going to factorize. Okay? What is common to both sides? I mean, what is common to 6x squared and plus 18x? That is 6x, right? So I'm going to have 6x x plus 3, right? This will be equals to 0. Okay? 6x equals to 0. And then x plus 3 equals to 0. Okay? X equals to 0 divided by 6. And x equals to minus 3. X equals to 0. And then x equals to minus 3. The stationary point of the function f of x equals to 2x to the power of 3 plus 9x squared is x raised to the x equals to 0 and x equals to negative 3. Now, the questioner proceeded and said we should find whether the stationary point, whether these points, they are maximum, minimum, or point of inflection. So that means that I'm going to use the second derivative test. I'm going to differentiate this function one more time. You understand? So for the second derivative test, I'm going to have the second derivative of f of x will be equals to, now, differentiate 6x squared. What are you going to have? That is 12x. I'm going to have 12x. Differentiate plus 18x. That will give me 18. Okay, plus 18. Now, this is the second derivative of the function. Now, at x equals to 0. Please pay attention. At x equals to 0. The second derivative of f of x will be equals to 12 multiplied by 0 plus 18. Do you know? So I'm going to have 12 times 0 is what? 0. I'm going to have 18. Okay? At x equals to minus 3. The second derivative of f of x will be equals to 12 multiplied by minus 3 plus 18. Do you know? So the second derivative of f of x will be equals to 12 times minus 3. That is what? Minus 36. Minus 36 plus 18. Okay? The second derivative of f of x will be equals to minus 36 plus 18 will give me negative 18. Minus 18. So now at x equals to 0, the second derivative of f of x is greater than 0. Do you know? Because at x equals to 0, the second derivative is what? 18. So therefore, that means that at x equals to 0, the stationary point is minimum. Do you understand? Because now the value of the second derivative of f of x is greater than 0. And don't forget the condition. For minimum point, the stationary point is minimum when the second derivative is greater than 0. Are you getting it? Now, when I substitute the value of x as 0 into the second derivative of f of x, I obtain a value which is 18. And if you compare, 18 is greater than 0. That means that the second at this point, at x equals to 0, that point is minimum. Do you understand? Okay. Now, for the second point, at x equals to 0, you have minimum. That is minimum. Minimum point. Minimum. The stationary point is minimum. And then at x equals to minus 3. Now, when x is minus 3, what do we have? We have negative 18. Now, negative 18 is less than 0. Do you understand? So, at x equals to minus 3, that point, the stationary point is maximum. Do you understand? At x equals to 0, the stationary point is minimum. At x equals to minus 3, the stationary point is maximum. Do you understand? Okay. For understanding, let me reiterate what I said. At stationary point, the function the first derivative will be equals to 0. So I take the first derivative. The first derivative is 6x squared plus 18x. I set this derivative, I set it equals to 0. Okay, then to get the value of x, I factorize. Okay, so I have 6x multiplied by x plus 3 equals to 0. 6x will be equals to 0. X plus 3 will be equals to what? 0. Okay, now x will be 0 over 6. That will be what? 0. X minus 3, x plus 3 equals to 0. X will be equals to negative 3. Okay, now all these 2 points are the stationary point of this curve. Yes, they are the stationary point of this function. Now, we want to determine whether the stationary point is maximum, minimum, or point of inflection. So therefore, I take the second derivative of f of x. Are you getting it? The second derivative of 6x squared is what? The second derivative of f of x, the first derivative is this. So differentiating this function one more time will give me the second derivative of f of x. Do you understand? Differentiate 6x squared, you're going to have 12x. I have this. Differentiate 18x, you're going to have what? Plus 18. So, having gotten the second derivative, I substitute the value of x as 0. So, I obtain the second derivative as 18. Now, according to the conditions I gave to you, if the second derivative is greater than 0, that means that the point is minimum. So, at x equals to 0, I got the second derivative as 18. That means that the point x equals to 0, it is minimum. Now, at x equals to negative 3, I substitute the value of x as negative 3. I obtain a value less than 0, which is negative 18. Of course, minus 18 is less than 0. So at x equals to minus 3, it is maximum because the condition is there that the second derivative, if it is less than 0, we have maximum. I get what I'm trying to say. So the stationary point is maximum at x equals to minus 3 and then minimum at x equals to 0. Do you understand? Let's consider the question that we have on the board. We are asked to find the stationary point of the function f of x equals to 1 minus 6x minus x squared and determine whether the stationary point is maximum, minimum, or point of inflection. Okay, don't forget that I told you at stationary point, the first derivative of a function is equals to 0. So we have to differentiate this function first. For this, I'm going to have derivative of f of x will be, now differentiate 1, you're going to have 0. Differentiate negative 6x, you're going to have negative 6. Differentiate negative x squared, you're going to have negative 2x, right? Okay. Having done this, the next step is that you have to set this derivative equals to 0. Do you understand? So I'm going to have negative 6 minus 2x equals to 0. To get the stationary point, you have to, get the value of x. I'm going to have negative 2x equals to minus, if this negative 6 crosses the equals to sign, it's going to change to positive. So I'm going to have plus 6. To get the value of x, divide all through by negative 2. This over x will be equals to what? Negative 3. Now, having gotten the value of x as negative 3, this point that you see here is the stationary point of the function f of x equals to 1 minus 6x minus x squared. Do you understand? Okay, now the next step is that we want to determine whether this stationary point is maximum, minimum, or point of inflection. So we are going to make use of the second derivative test. Do you understand? So I'm going to differentiate this function one more time. So the second derivative of f of x will be equals to differentiate minus 6. I'm going to have 0. Differentiate negative 2x. You're going to have minus 2. Okay. Now, because the second derivative of f of x is less than 0, that means that the stationary point x equals to minus 3 is a maximum. Do you understand? The stationary point is a maximum point. Do you understand? Because the second derivative test is equals to negative 3. Don't forget, if the second derivative is less than 0, and because negative 3 is less than 0, that means that this point is maximum. Do you understand? Okay, let's look at more work example on stationary points. Okay, find the stationary point of the function f of x, of the curve f of x equals to 12x minus x squared, and determine whether the stationary point is maximum, minimum, or point of inflection. Okay, to do this, the first step is that we have to take the first derivative of f of x. So the first derivative of f of x will be equals to 12 minus 2x, right? So to get the value of x, I'm going to set the first derivative equals to 0 because at stationary point, the first derivative of the function is equals to 0. So I'm going to have 12 minus 2x equals to 0. Minus 2x equals to minus 12. Divided by negative 2. X equals to what? 6, okay? Now, the stationary point of this function, of this curve is 6. Now, to get whether the maximum or minimum, whether this stationary point is maximum or minimum, we use the second derivative test, okay? Let us differentiate this function one more time. I'm going to have the second derivative of f of x will be equals to differentiate 12, you're going to have 0. Differentiate minus 2x, you're going to have minus 2, okay? Now, because the second derivative test, which is f of x, is less than 0, that means that the stationary point x equals to 6 is a maximum point. Is maximum. Let's just feel like that. The stationary point is maximum at x equals to 6 because the second derivative of f of x is less than 0, okay? Now, let us look at more work question on stationary point, okay? Let's consider this question on stationary point. We are asked to find the stationary point of the curve y equals to x multiplied by x minus 1 squared plus 1. Okay, before we proceed, let us expand what we have here. I can rewrite y as y equals to x multiplied by x minus 1, x minus 1, then plus 1, okay? Y is equals to x multiplied by x times x is x squared. X times negative 1 minus x. Minus 1 times x minus x. Minus 1 times minus 1, that is plus 1. Plus 1, okay? Y equals to x multiplied by x squared minus 2x plus 1 plus 1, okay? Y equals to x raised to the power of 3 minus 2x squared plus x plus 1. Okay, so the function y equals to x multiplied by x minus 1 squared plus 1 can be written as this. Now, don't forget that at stationary point, the first derivative of the function is equals to 0. So I'm going to take the first derivative of this function. Derivative of y is equals to differentiate x cubed. I'm going to have 3x squared minus 4x plus 1, okay? Now, I'm going to set this derivative equals to 0 because what I'm looking for is the stationary point. And at stationary point, the derivative of the function is equals to 0. So I'm going to have 3x squared minus 4x plus 1 equals to 0, okay? Now, to do this, I'm going to factorize, you understand? Okay, I'm going to have 3x squared minus 3x minus x plus 1 equals to 0, okay? 3 multiplied by x. Okay, use 3x. 3x multiplied by x minus 1, okay, plus 1 multiplied by x minus 1. Do you understand? Hello? Oh, sorry, it should be minus 1. Minus 1 multiplied by x minus 1. Do you understand? Okay, what I did was that I just factorized. So I'm going to have 3x minus 1 equals to 0. X minus 1 equals to 0. 3x equals to 1. To get the value of x, divide by 3. X equals to 1 over 3. For this, I'm going to have x equals to 1. So the stationary point of the function y equals to x multiplied by x minus 1 to the power of 2 plus 1 is 1 over 3 or 1. 1 over 3 or 1. Now listen, this stationary point can be maximum, minimum, or point of inflection. So we want to check what is the nature of the stationary point. We want to distinguish between the stationary point, okay? And to do that, we are going to use the second derivative test, okay? Now, for the second derivative test, let's differentiate this function one more time. I'm going to have the second derivative of f of x will be equals to differentiate 3x squared. You're going to have 6x, right? Differentiate negative 4x. You're going to have minus 4, right? Okay. Now, the second derivative of the function is what? 6x minus 4. Now, let us substitute each stationary point. Substitute each stationary point into this. So, at x equals to 1 over 3. At x equals to 1 over 3, The second derivative will be equals to 6 multiplied by 1 over 3 minus 4. Okay. 3 here 1, 2. 2 times 1 is what? 2. 2 minus 4 is equals to what? Negative 2. Okay. Now at x equals to 1, at x equals to 1, I'm going to have the second derivative will be equals to 6 multiplied by 1 minus 4. So I'm going to have 6 times 1 is 6 minus 4. 6 times 1 is 6 minus 4 is what? 2. So I'm going to have this will be 2. So at x equals to 1 over 3, the second derivative is what? Minus 2. At x equals to 1, the second derivative is what? 2. Now, at x equals to 1 over 3, the second derivative is less than 0. Do you know? Negative 2 is less than 0. Second derivative is less than 0. So this point is maximum. Do you understand? Maximum. Okay, the stationary point x equals to 1 over 3 is maximum because the second derivative of the function is less than 0. Now, what of this? At x equals to 1, we have the second derivative as what? As 2, which is what? Greater than 0. So the second derivative for this is minimum because now the second derivative is greater than 0. Of course, 2 is greater than 0. So therefore, at x equals to 1, we have minimum. We have minimum point. And at x equals to 1 over 3, that is maximum. Do you understand? So you can always do, you can always check, you can always find the stationary point of a function or a curve and determine the nature of the stationary point. Okay, now let us look at more work example on stationary points. Find the stationary point of the function y equals to 24x plus 3x squared minus x raised to the power of 3 and determine whether they are maximum, minimum, or point of inflection. Okay, to do this, let us take the first derivative of y. Derivative of y is equals to 24 plus 6x minus 3x squared, right? Then, having done this, you set the first derivative equals to 0. So I'm going to have 24 plus 6x minus 3x raised to the power of 2 equals to 0. Do you understand? Okay, having gotten to this point, you can reduce this. Are you getting it? So I'm going to have this divided by 3, this divided by 3, and this divided by 3. 24 divided by 3 will give me 8. So I'm going to have 8 plus 2x minus x squared equals to what? 0. Okay, having gotten to this point, the next step is that you have to factorize. I'm going to have 8 plus 4x minus 2x minus x squared equals to 0. Okay, what is common to 8 and 4x? That is what? 4 into bracket 2 plus 1x minus x into bracket 2 plus 1x. Okay, don't forget that 1x is also the same thing as what? X. Do you understand? So you can just put it as 2 plus x, 2 plus x. Do you get it? So for this, I'm going to have 2 plus x equals to 0. And then 4 minus x equals to 0. Okay, x will be equals to what? Minus 2 here. And minus x will be equals to minus 4. X will be equals to what? 4. So the stationary point is minus 2, 4. Are you getting it? If you didn't understand what I did, you know that I reduced this equation by dividing all through by 3 because I'm very certain that if I divide all through by 3, I'm going to arrive at an equation with a lower coefficient. And are you getting what I'm trying to say? So I divide all through by 3, I obtain this. So I factorize normal quadratic equation. So I got this. Are you getting it? So having factorized, I arrive at x equals to minus 2 and 4. Now, the stationary point of the function y equals to 24x plus 3x squared minus x to the power of 3 is minus 2 and 4. The next question says we should determine we should distinguish between this stationary point as to whether they are maximum, minimum, or point of inflection. Okay. Now, to distinguish between the stationary point, we need to take the second derivative. That means we're going to differentiate this one more time. So I'm going to have derivative of y second is equals to differentiate 24, you're going to have 0. Differentiate 6x, you're going to have 6. So I'm going to have 6. Differentiate negative 3x squared, you're going to have minus 6x. Do you understand? Okay, now let us test. At x equals to -2, we want to test at x equals to -2. Second derivative of y will be 6 minus 6 multiplied by -2. Do you know? At x equals to -2, I'm going to substitute the value of -2 as x into this. So I'm going to have 6 minus 6 multiplied by -2. Second derivative will be equals to 6 plus 12, and that is what? 18. Now, you can see that the second derivative is 18, and 18 is what? Is greater than 0. And because 18 is greater than 0, that means that the second derivative is greater than 0 at x equals to -2. And since that happens, that means it is what? Minimum point. You see? Minimum point. The second derivative is greater than 0. So this one is minimum. Minimum. Now, let us test for x equals to 4. At x equals to 4, I'm going to have the second derivative as 6 minus 6 multiplied by 4. Do you know? So I'm going to have 6 minus 24. Do you understand? 6 minus 24 is 18. So I'm going to, negative 18, sorry. And negative 18. And that is what? Less than 0. So at x equals to 4, the stationary point is maximum. Do you understand? We have maximum. At x equals to 4, it is maximum. And at x equals to -2, it is minimum. Do you understand? Okay, so that's how it works. Let's look at more work example on this concept, stationary point. Okay. Consider the question that we have on the board. We are asked to find the stationary point of the curve 4x raised to the power of 3 over 3 minus 4x squared plus 2, and determine whether whether the stationary point is maximum, minimum, or point of inflection. Okay, to do this, let's first take the first derivative. As stationary point, the first derivative is equals to 0. In fact, I can write as this: dy all over dx is equals to 4 times 3 x raised to the power of 2 all over 3 minus 4 times 2x. Then if you differentiate 2, you're going to have what? 0. So for this, I'm going to have this 3 will eliminate this 3. So I'm going to have dy all over dx will be equals to 4x to the power of 2. Do you get it? Minus 8x. Do you understand? Okay, as stationary point, the first derivative of that function is equals to 0. So I'm going to have 4x raised to the power of 2 minus 8x equals to 0. Do you understand? Okay, let us get the value of x. I'm going to have 4x, x minus 1 equals to 0. Oh, x minus 2, sorry. X minus 2 equals to 0, okay? Now, 4x equals to 0, x minus 2 equals to 0. X equals to 0 because 0 divided by 4 will give me 0. X equals to 0 or x equals to 2. So therefore, the stationary point of this function is 0, 2. Now, having gotten the stationary point, we want to check whether the stationary point is maximum, minimum, or point of inflection, okay? So let us use the second derivative test. Hence, I'm going to differentiate this function one more time. Do you understand? So I'm going to have the square y all over the x squared will be equals to, now, differentiate 4x squared. I'm going to have 8x, right? Differentiate minus 8x. I'm going to have minus 8. Are you getting it? Now, at x equals to 0, the square y all over the x squared will be equals to 8 times 0 minus 8. 8 times 0 minus 8 will give me minus 8. Do you understand? So at x equals to 0, we have minus 8. Minus 8 is less than 0. Do you know? So therefore, at x equals to 0, it is what? Maximum point. It is maximum. Maximum at x equals to 0. Now, let us check at x equals to 2. At x equals to 2, the square y all over the x squared, that is the second derivative of the function, will be 8 multiplied by 2 minus 8. 8 times 2 is 16. 16 minus 8 is what? 8. So you can see that at x equals to 2, the square y over the x squared is greater than 0. And if the square y over the x squared is greater than 0, that means that we're going to have a minimum point. Do you understand? So at x equals to 2, the point here is minimum. Do you understand? You can see that it is simple. Okay? This is the step. Anytime you're asked to find the stationary point, differentiate the function first. Are you getting it? Get the value of the variable. And then to check whether the stationary point is maximum, minimum, or point of inflection, take the second derivative of that function, and then you substitute the value of x as you substitute each value of x, and then to get the value of the second derivative. And in some cases, you might not have x as one of the variable when you take the second derivative. So you can always have your answer. Do you understand? I've done some of the cases whereby when we take the second derivative, we have a single value. That is, we don't have variable x present in the second derivative again. In that case, you can always you get your answer directly. For example, let's say by the time I take the second derivative of this function, I got maybe 8. You can see that 8 is 8 is greater than 0, right? That means that the second derivative is greater than 0. That is minimum point. Are you getting it? But I discovered that when I take the second derivative, I have 8x minus 8. So I have to substitute each values of x. Do you understand? Okay, now let's look at more work example on stationary point of a function. Okay, let's consider this question on stationary point. Find the stationary point of the curve x squared minus 4x minus 6. F of x equals to x squared minus 4x minus 6. Okay, we are asked to find the stationary point and to check whether the stationary point is maximum, minimum, or point of inflection. Okay, for this, I'm going to have take the first derivative of the curve. I'm going to have f of x derivative is equals to 2x minus 4, right? Set this derivative equals to 0 because at stationary point, the first derivative of a function equals to 0. So I'm going to have 2x minus 4 equals to 0. 2x equals to 4. X equals to what? 4 over 2. X equals to 2. So the stationary point of the function x squared minus 4x minus 6 is x equals to 2. Now, the second question says I should determine whether the stationary point is maximum, minimum, or point of inflection. Okay, I want to do something now. Pause this video, and then when you are done, play the video and check whether your answer is correct. Do you understand? Okay, now let us take the second derivative. The second derivative of f of x is 2. Do you know? Because if you differentiate 2x, you're going to have 2. Differentiate negative 4, you're going to have 0. Are you getting it? So the second derivative of f of x is 2. Now, listen to me. This is what I'm trying to explain the other time. You can see that here, when I take the second derivative, I have maybe something like a variable x is still present. So I have to substitute the value of that stationary point. But in this question, when I take the second derivative, immediately I got 2. So there is no need of substitution. So since the second derivative is greater than 0, go back to your condition. If the second derivative is greater than 0, what is the nature of that stationary point? That will be what? Minimum. Do you understand? Because 2 is greater than 0. So at x equals to the stationary point x equals to 2 is minimum. Do you understand? Okay, we have minimum point. You can see that it's simple. Okay, let's look at more work example on stationary point of a function. Or let me give you an assignment. Okay, let me give you an assignment. We are still I'm not done with the class, so I just want to give you a question that you can practice on your own. Find the stationary point of the curve x squared minus 8x and test whether it is maximum, minimum, or point of inflection. Another question. Find the stationary point of the curve f of x equals to x squared minus 2x minus 3 and check whether the stationary point is maximum, minimum, or point of inflection. Okay, so we are still on stationary point. I'm not done with the class. Okay, let's consider the question that we have on the board. We are asked to find the stationary point of the function f of x equals to x to the power of 4 minus x raised to the power of 3 plus x squared plus 1. And we should distinguish between the stationary point as to whether it is maximum, minimum, or point of inflection. Okay. Now to do this, the first step is that at stationary point, the first derivative of a function is equals to 0. So I'm going to take the first derivative of f of x. So the first derivative of f of x will be equals to 4x to the power of 3 minus 6x to the power of 2 plus 2x, right? So I'm going to set this function equals to 0. 4x to the power of 3 minus 6x to the power of 2 plus 2x equals to 0. The next thing I'm going to do is that I'm going to divide all through by 2x, okay? Or just divide by x, or 2x. This over 2x, this over 2x, and this over 2x. This as well over 2x. I'm going to have 2x raised to the power of 2 minus 3x plus 1 equals to 0, right? So now we have a quadratic equation. Hello? Listen to me carefully. If you don't want to do it like this, you can factorize. Listen, you can factorize. We have 4x raised to the power of 3 minus 6x raised to the power of 2 plus 2x equals to 0, right? You can factorize 2x. What are you going to have? 2x multiplied by 2x raised to the power of 2 minus 3x, right? Plus 1 equals to 0, right? So you're going to have 2x equals to 0 and 2x squared minus 3x plus 1 equals to 0. Is that not it? It's still the same. You can see we still arrive at the same answer. Do you understand? So for this, I'm going to have x equals to 0 over 2. X equals to 0, right? Which is the first root of this equation. Now, to get the second and the third root, I'm going to solve this quadratic equation simultaneously. Do you understand? So I'm going to have 2x squared minus 2x minus x plus 1 equals to 0, okay? So factorize, I'm going to have 2x multiplied by x minus 1 plus 1 multiplied by x minus 1. Or minus 1. Minus 1 multiplied by x minus 1. This will be equals to 0. 2x minus 1 equals to 0. X minus 1 equals to 0. 2x equals to 1. X equals to 1. X equals to 1 over 2 or 1. That is the root of this equation. Having differentiated, that is what? X equals to 0, 1 over 2, and 1. All these three roots are the stationary point of the polynomial equation 4x raised to the power 3 minus 6x squared plus 2x equals to 0. X equals to 0, 1 over 2, or 1. Now, having gotten the value of x, these are the stationary points. The stationary points are these. Now, we want to check whether the stationary point is maximum, minimum, or point of inflection using the second derivative test. And I want you to pay attention. That means I'm going to take the second derivative of f of x. So if this is the the first derivative, the second derivative will be differentiate 4x to the power of 3. I'm going to have 12x to the power of 2. Differentiate negative 6x squared. You're going to have negative 12x. Okay? Differentiate plus 2x. You're going to have what? Plus 2. Okay? Now listen. At x equals to 0. Please listen to me carefully. At x equals to 0, the second derivative of f of x will be 12 multiplied by 0 squared minus 12 multiplied by 0 plus 2. The second derivative of f of x will be equals to 2. Now, because 2 is greater than 0, that means that at x equals to 0, we have minimum. This is minimum point. You understand? Minimum, okay? Are you getting it now? At x equals to 1 over 2, okay? At x equals to 1 over 2, I'm going to have the second derivative of f of x will be 12 multiplied by 1 over 2 squared, right? Minus 12 multiplied by 1 over 2 plus 2. Okay, let's go. The second derivative of f of x will be equals to 12 multiplied by 1 over 4 minus 12 all over 2 plus 2. The second derivative of f of x will be 3 minus 6 plus 2, right? So the second derivative of f of x will be 3 plus 2 is what? 5. Minus 6 plus 5, that is what? Minus 1. Now, at x equals to 1 over 2, the second derivative of f of x is negative 1. And negative 1 is less than 0. Yes, negative 1 is less than 0. So that means that at x equals to 1 over 2, that is, we have maximum point. Maximum point. Because negative 1 is less than 0. And if the second derivative is less than 0, that point is maximum. Do you understand? So now we are done with x equals to 0, x equals to 1 over 2. Now let us test for x at x equals to equals to 1, because now we have 3 points. We have x equals to 0, x equals to 1 over 2, and x equals to 1. Are you getting it? So let us test for x equals to 1. At x equals to 1, the second derivative will be equals to 12 multiplied by 1 squared minus 12 multiplied by 1 plus 2. Okay, I'm going to have 12 minus 12 plus 2. So I'm going to have 2. So at x equals to 1, the second derivative is 2. Now, the second derivative is 2. That means that it is greater than what? It is greater than 0. That means that this point is what? Minimum. Minimum point. Minimum point. Okay? So at x equals to 0, it is minimum. At x equals to 1 over 2, it is maximum. At x equals to 1, it is minimum point. Now, you can get the corresponding values of y. Are you getting it? Like, you can get the corresponding value of f of x by substituting all these values. Okay, x equals to 0. You're going to have, at x equals to 0, you're going to have how many points like that? You're going to have 1, 0, 1. That is minimum point. Now, at x equals to 1 over 2, you're going to have 1 over 2 raised to power 4. That is 1 over 16. 1 over 16 minus 2 multiplied by 1 over 8 plus 1 over 4 plus 1. What I did was that I just substitute the value of x as 1 over 2. Do you understand? I want to get the corresponding value of f of x, the second value. You know, at every point, we always have two coordinates. You understand? Coordinate x, y. Are you getting what I'm trying to say? So I just want to get the corresponding value. Having determined the nature of the point. So x is 0 here. That means that 0, 1 will be what? 0, 1 will be minimum point. This is minimum. Now, x is 1 over 2 and it is maximum. I substitute the value of x as 1 over 2 into this. I have 1 over 16 minus 2 multiplied by 1 over 8 plus 1 over 4 plus 1. So for this, I'm going to have 1 over 16 plus 1 over 4 minus 1 over 4 plus 1 over 4 plus 1. So this will cancel this. I'm going to have 1 over 16 plus 1. 16 plus 1. That is what? 17 all over 16. Okay. So at this point, I'm going to have 1 over 2, 17 over 16. This is maximum. And then for the third one, which is 2. For the third one, which is at x equals to 1. So when x equals to 1, I'm going to have 1 raised to power 4 minus 2 multiplied by 1 raised to power 3 plus 1 raised to power 2 plus 1. 1 minus 2 plus 1 plus 1. 1 plus 1 is 2. 2 minus 2 is 0. So I'm going to have, for this, I'm going to have 1, 1. That is what? Also minimum. Yes, it is minimum because x is equals to 1. And derivative of x, and the second derivative of x is what? 2. Do you understand? Okay. So that is the solution to that question. You can see that it's simple. All you have to do is just pay attention and follow the process, and you're going to obtain an answer that is correct. Okay. So let us look at more example on stationary point of a function. Let's consider the question that we have on the board. We are asked to find the stationary point of the function f of x equals to x squared multiplied by x squared minus 2, and determine whether the stationary point is maximum, minimum, or point of inflection. Okay, don't forget that a stationary point, the first derivative of a function is equals to 0. So I'm going to differentiate f of x. But before that, let us open this bracket using x squared. So I'm going to have f of x is equals to x raised to the power of 4 minus 2x squared. Because x times x raised to the power of 2 is what? X to the power of 2 times x to the power of 2. That will be x to the power of 4. X to the power of 2 times negative 2. That is negative 2x squared. Are you getting it? Okay. Having gotten to this point, take the derivative of f of x. I'm going to have 4x raised to the power of 3 minus 4x. Do you understand? Okay. Having gotten to this point, the next step is that you have to set this derivative equals to 0. So I'm going to have 4x raised to the power of 3 minus 4x equals to 0. Okay, you can divide all through by 4 to reduce the equation. So I'm going to have this over 4, this over 4, and this over 4. So I'm going to have x raised to the power of 3 minus 4 equals to, minus x, sorry, minus x equals to 0. Do you understand? Okay, having gotten to this point, you can factorize. Are you getting it? You can factorize x because x is common to both of this term and this term. So I'm going to have x multiplied by x squared minus 1 equals to 0. Do you understand? Okay, having gotten to this point, you can set x. The first factor will be x equals to 0 or x squared minus 1 equals to 0, right? So I'm going to have x equals to 0, x equals to, x squared equals to 1, x equals to 0, x equals to plus or minus the square root of 1. Okay, x equals to 0, x equals to negative 1, comma 1. So the stationary point is this, x equals to 0, minus 1 or 1. These are the stationary points. Do you understand? Okay, having gotten the stationary point, we can now determine whether all these points is maximum, minimum, or point of inflection using the second derivative test. Okay, let us do that here. Okay, that means that I'm going to differentiate this. I'm going to take the second derivative of f of x. Are you getting it? So for this, I'm going to have f of x. The second derivative will be equals to. Now differentiate this once again. I'm going to have 12x minus 4. 12x squared minus 4. Do you know? Because 4 times 3 will be giving me 12. And the power reduced by 1. That is what? X squared. If you differentiate negative 4x, you're going to have negative 4. Now, at x equals to 0, I'm going to have the second derivative as 12 times 0 squared minus 4. That is what? 0 minus 4. That is minus 4. So at x equals to 0, that point is negative. The second derivative is negative 4. And because the second derivative is negative 4, that means that it is maximum. Do you understand? So at x equals to 0, it is maximum. Maximum. Okay, maximum. Now, let us test for x equals to negative 1. At x equals to negative 1, the second derivative of x will be equals to 12 multiplied by negative 1 squared minus 4, right? So I'm going to have 12 times 1, that is 12. 12 minus 4, that is 8. So the second derivative is equals to 8. So you can see that 8 is greater than 0. And if you have the second derivative, if the second derivative of the function is greater than 0, that means that the point is minimum. Do you understand? Okay. Now let us test for x equals to 1. The second derivative will be equals to 12 multiplied by 1 squared minus 4. Okay. So I'm going to have 12 times 1 squared is what? 1. 12 times 1 is 12. 12 minus 1 as well will give me, 12 minus 4, that is 8. So you can see that at x equals to 1, the second derivative is what? Is 8. The second derivative is greater than 0. So at x equals to 1, it is also what? Minimum. Do you understand? So at x equals to 0, it is maximum. X equals to negative 1, minimum. X equals to 1, minimum. Now, you can get the corresponding value, the second value. You understand? You know, at every point, you have to coordinate. You understand? So, you can get the corresponding value of f of x when x is 0. When x is 0, f of x will be what? 0, right? Yes. Okay, I'm coming, please. Excuse me. Let me erase this so as to help you to understand what I'm doing. You can get the corresponding value of f of x. When x is 0, I'm going to have f of x will be equals to f of x is x squared minus 2. Now, when x is 0, I'm going to have f of 0 will be what? 0 multiplied by 0 minus 2. That is what? 0. So, at minimum point, this is what? 0, 0. Okay? Minimum. When x is negative 1, I'm going to have f of negative 1 will be what? Negative 1 squared multiplied by negative 1 squared minus 2, right? So I'm going to have Negative 1 square is 1. Negative 1 square is also what? 1. 1 minus 2 is what? Minus 1. So I'm going to have 1 multiplied by minus 1. That is what? Minus 1. So the second point is what? 1 comma minus, okay, minus 1 comma minus 1. Minus 1 comma minus 1, okay? Now, what of when x is 1? I'm going to have f of 1 will be 1 squared multiplied by 1 squared minus 2, okay? 1 squared is 1. 1 squared is 1. 1 minus 2 is what? Negative 1. 1 multiplied by negative 1, that is what? Negative 1 comma negative, okay, 1, sorry. X is 1 now, so I'm going to have 1 comma negative 1. That is the third point. That is the third point. You understand? Don't forget that this point at x equals to 0, that is maximum, minimum, Abi? Is it minimum? Yes, it is minimum. Maximum, minimum. Yes, it is minimum. Yes, minimum. Okay, so that is the solution to that question. Do you understand? Okay, let us look at more work example on stationary point. Okay, so kindly follow me to the end of this class. Find the stationary point of the function 2x squared minus x raised to the power of 4 and determine whether it is maximum, minimum, or point of inflection. We are asked to find the stationary point. Please pay attention. We are asked to find the stationary point of the function 2x squared minus x to the power of 4. 2x squared minus x to the power of 4, okay? At stationary point, the first derivative of a function is what? Is 0. So I'm going to have f of x derivative is equals to 4x minus 4x to the power of 3, right? So 4x minus 4x to the power of 3 equals to 0, right? Divide all through by 4. I'm going to have x minus x raised to the power 3 equals to 0. X into bracket 1 minus x squared equals to 0. X equals to 0 first. 1 minus x squared equals to 0. Minus x squared equals to minus 1. Minus x, okay. X squared equals to 1. X equals to plus 1 or minus 1. So the stationary point is 0, 1, and minus 1. Do you understand? Okay, now we want to check whether the stationary point is maximum, minimum, or point of inflection. So to do that, we are going to make use of the second derivative test. Do you understand? Now, the second derivative of f of x will be equals to, now differentiate this one more time. I'm going to have x minus 12x raised to the power 2, okay? Now at x equals to 0, the second derivative of x will be equals to 0 minus, listen, 0, sorry. I hope I didn't make any mistake. Okay, sorry, I made a mistake. There is a mistake here. The second derivative of f of x. This is the first derivative, okay? Differentiate 4x minus 4x to the power of 3. You're going to have 4 minus 12x raised to the power of 2. Do you understand? Okay, I made a mistake before. Now, I've already corrected the mistake. Now, at x equals to 0, I'm going to have f of x as 4 because 0 square is what? 0. Negative 12 times 0 will give me 0. 4 minus 0 is what? 4. So at x equals to 0, the second derivative is what? Is greater than 0. And that point is what? Minimum. So at x equals to 0, we have minimum point. Now at x equals to 1, we're going to have the derivative of the second derivative will be equals to 4 minus 12. 4 minus 12. Are you there? Because 1 square is 1. Negative 12 times 1 is what? Negative 12. 4 minus 12 is negative 8. So the second derivative of f of x is minus 8. Okay? That means that minus 8 is less than 0, right? Yes. Then minus 8 is less than 0. That means that this point is maximum. Are you getting it? Maximum. Now, let us get the third point. We have negative 1. When x is negative 1 at x equals to negative 1, I'm going to have the second derivative of f of x will be equals to -8 as well. Do you know the reason? If you substitute the value of x as -1, -1 square is what? 1. 1 times -12, -12. 4 minus 12 is what? -8. So at x equals to -1, the point is also maximum. You understand? Because now the second derivative is less than 0. Do you understand? Okay, so I've done the second derivative test. Now you can get the corresponding value of the second value or the corresponding value of f of x by substituting the value of all these x into this equation. Are you getting it? So for the first one, x equals to 0. I'm going to have 0, 0. X equals to 1. I'm going to have 2 minus 1. That is what? 1, minus, okay, 1, 1. Okay. Now for the third point, I'm going to have -1. Yes. Oh, sorry, I made a mistake. Yes, it's still the same. Substitute the value of x as 1 in this place. I'm going to have 2 minus 1. That is 1, 1. Okay. Now substitute the value of x as -1. I'm going to have 2 minus 1 raised to the power of 4. That is what? 1. 1 times -1. That is -1. So I'm going to have 2 minus 1, which is what? 1. 1, 1. Do you understand? Okay, so that is the solution to that question. So let me do a recap on what we've learned in this class. I start by explaining what is meant by stationary point. A stationary point, the rate of change of a curve or a function is momentarily 0. You understand? If you have a curve, listen to me. If you have a curve, when the curve is changing from the positive value to negative value, before that happens, it's going to get to a point where it's going to get to point 0. That point is what we call stationary point. Do you understand? It's just as if you are counting. Hello, if you are counting a negative number towards the positive number, for example, -2, -1, you're going to get to 0, right? At that point, the rate of change of that function is 0. That point is called stationary point. Are you getting it? So in context, stationary point is a point whereby the rate of change of a function is momentarily 0. Do you understand? Okay, when the curve is changing from negative to positive or from positive to negative. Do you understand? Okay, so that's it. And as stationary point, we can have maximum, it can be minimum, or it can be point of inflection. The difference depends on the second derivative test. When you use, there are many tests. Are you getting it? There are many other tests, but I prefer using the second derivative test in this class. So, if you differentiate the function the second time, if you discover that the second derivative is equals to 0, the stationary point is point of inflection. Now, if you discover that the second derivative is greater than 0, the stationary point is minimum. Are you getting it? If it is greater than 0. Now, if the second derivative is less than 0, the stationary point is maximum. Do you understand? So I just did a recap of what we've learned in this class. If you have any question, let me know in the comment section. Okay, so that will be all for this class. See you in the next class. And before you go, don't forget to hit the like button, subscribe.